In this lecture, we will learn about the trigonometric functions that the Python math module gives us access to. Up at the top of the code, we need to import the math module. The cos function will return the cosine of x in radians. For example, let's print out math.cos and pass in 90. When we run the code, notice that negative 0.448 was printed to the console. The sine function will return the sine of x in radians. For example, we can print out math.sine and pass in 90. When we run the code, notice that 0.893 was logged to the console. The tan function will return the tangent of x in radians. For example, let's print out math.tan and pass in 90. When we run the code, notice that negative 1.995 was printed to the console. The a-cos function will return the arc cosine of x in radians. If we print out math.acos and pass in 0 and then run the code, you will notice that 1.570 was printed to the console. The a-sine function will return the arc sine of x in radians. For example, let's print out math.asine and pass in 0. When we run the code, you will notice that 0 was printed to the console. The a-tan function will return the arc tangent of x in radians. For example, we can print out math.atan and pass in 0. When we run the code, you will notice that 0 was logged to the console. The dist function will return the distance between 2 points. For example, we will create a variable named point1 and set it to a point 00. Then we will create a variable named point2 and set it to a point 62. Finally, we will print out the result of a call to math.dist and pass in point1 as the first argument and point2 as the second argument. When we run the code, notice that 6.324 was printed out. The hypot function will return the hypotenuse of a triangle with the coordinates we pass into the function. First, we will create a variable named perpendicular and assign it a value of 4. Then we will create a variable named base and set it equal to 3. After that, we will print out the result of a call to math.hypot and pass in perpendicular as the first argument and base as the second argument. When we run the code, notice that 5 was printed out. If you're familiar with the Pythagorean theorem, you probably recognize that it would be 5 since this is a 3-4-5 triangle, one of the most common right triangles in all of mathematics. In the next lecture, we will learn about the angular conversion functions that the Python math module gives us access to. In this lecture, we will learn about the angular conversion functions that the Python math module gives us access to. If you are familiar with the mathematical concepts of angles, then you probably know what radians and degrees are. But I will review the basics in case you are unfamiliar with these terms. A degree is a mathematical unit of measurement. There are 360 degrees in a circle. There are 180 degrees in a straight line. A 90-degree angle is created by two perpendicular lines. A radian is a degree times 180 divided by pi. As you can imagine, doing conversions like this by hand can get messy really quick. Thankfully, Python's math module gives us two important functions for converting between degrees and radians, the degrees function and the radians function. For this example, the first step is to import Python's math module at the top of our program. Let's say we want to convert 5 radians to degrees. The math module's degree function takes in a value in radians and converts it to degrees. We can use Python's print function and pass in the result of math.degrees with 5 passed in as the radian value to be converted to degrees. When we run the code, you will notice that 286.4788, etc. was printed to the console. If we want to convert degrees to radians, we can use the math module's radians function. Let's print out the result of math.radians and pass in a value of 90 into that function. When we run the code, you will notice that 1.5707, etc. was printed to the console. In the next lecture, we will learn about the hyperbolic functions that Python's math module gives us access to. In this lecture, we will learn about the hyperbolic functions that Python's math module gives us access to. At the top of the program, we will import Python's math module by typing import math. The sine function will return the hyperbolic sine of the value we pass in. For this example, we will use Python's print function and print out the hyperbolic sine of 3.0 using the math module's sine function. When we run the code, you will notice that the value printed is the hyperbolic sine of 3.0. Similarly, the math module allows us to get the hyperbolic cosine of a value using the cos function. For this example, let's get the hyperbolic cosine of negative 2.0 and print it to the console. When we run the code, you will notice that the hyperbolic cosine of negative 2.0 was printed to the PyCharm console. As you may have guessed, Python's math module also gives us the tanh function to obtain the hyperbolic tangent of a value. For example, we can print out the value of math.tanh and pass in 0.3. When we run the code, you will notice that the hyperbolic tangent of 0.3 was printed out. Just like we can use Python to get the hyperbolic sine, cosine, and tangent for certain values, we can also use Python to get the inverse hyperbolic sine, cosine, and tangent. For example, we can print out the result of a call to the math module's a-sin-h function and pass in 90. When we run the code, you will notice that the inverse hyperbolic sine of 90 was output. We can also print out the result of the inverse hyperbolic cosine of 90 using the a cos h function. When we run the code, notice that the inverse hyperbolic cosine of 90 was output. And of course, we can get the inverse hyperbolic tangent of a value using the a tan h function. When we pass in a value of 0.2 and run the code, notice that we get the inverse hyperbolic tangent of 0.2 output to the PyCharm console. In this lecture, we will go over the answer to the coding exercise. For this coding exercise, we need to convert a Fahrenheit number to Celsius. Since we are given the formula, this should be pretty straightforward. We just need to convert the words from the problem into a formula. We can return Fahrenheit minus 32 and multiply it by 5/9. That will do the trick. With a problem like this, just take what you are given and go step by step translating the words into a numerical formula. In the next lecture, we will look at a recap of what we learned in this section of the course. First, we took a look at Python's math module and got an overview understanding of what it is and what it does. Then we learned about the different constant values that it contains. Next, we looked at the number theoretic and representation functions that it gives us access to. We then learned about the different power and logarithmic functions in the math module. After that, we got an understanding of the trigonometric functions contained in the math module. Then came a lecture on angular conversion functions. Next, we learned about hyperbolic functions. Finally, we did a coding exercise to test our knowledge of the material taught in this section of the course.